Hello, my name is Shalina, and today I'll be going through the static dynamic analysis for the LuckyCat malware. So, firstly, when the LuckyCat malware is downloaded and unzipped, malware.exe file is the malware with a .exe file extension is seen. So on running this malware.exe, it states that the app cannot be run, and to check with the software publisher to find the version for the PC. So after putting it through the PE view and analyzing the image file headers, we can identify that this malware file is not a .exe, instead is a .dll file. As such, the file extension was changed. And in order for a .dll file to run, it requires the run32dll.exe file, which is provided within the Windows system, as well as the export function callable by the malware. So using the dependency worker tool, we identify the get object count function, and we use it to run the malware. So before we perform the static dynamic analysis, we prepare the tools. So we will be running the tools to capture the processors, followed by the tools to capture the network activity, and lastly the tools to capture any registry activities that takes place by the malware. So in order to capture any network activity within the system, the netcat running on ports 80, 110, as well as 443 was configured. So other than this ports being configured, the Apate DNS was also set up with the DNS reply IP of 127.0.0.1, which is the local host, which is a loopback address. So after which the server is started, and the run dll32.exe command was run with the malware.dll file and the get object count, which is the function call for the malware.dll file. So upon execution of the malware, we are able to see that there is some network activity being sent to a specific domain. So we are also able to see that on port 110 there was a connection that was established, and there was no connection that was established on port 443. So this information sent on port 110 was encrypted, and doing a little bit of research on port 110. Port 110 is port 3, is the port for port 3, and port 3 is usually used for a mail server. So it's likely that the malware is sending a mail with some information towards this specific domain. So upon searching up this domain within the virus total tool, we are able to see that 6 vendors have actually flagged this domain as malicious, and within the relations tab, we are able to see that there were 3 communicating files that were found, and one of it and this file being the hash of the SHA1 hash of the malware.dll file that we are using. So after capturing the network activity, we will next proceed to analyze the processes created by the malware. So to monitor these processes created by the malware, the Process Explorer tool as well as the Process Monitor tool is used. So the malware is ran, and after the malware has been ran, looking at the Process Explorer, we try to identify any new processes that was created. In this case, the processor that was created was the run dll32.exe, and to confirm that the to confirm that the malware is running, when we'll view the lower pane and within the DLLs, we should be able to see a malware.dll. So this malware.dll is being concealed as the Windows Credential Manager under its description. So looking at the properties of this malware.dll, we are able to notice that there are strings. So there are strings of between the image and the memory. So to check and to view if there is any changes made within the strings are copied out. And a online text comparer is used. So copying out the information that was being saved of the strings. We input the image on one side and the memory on the other side. So after which we click the compare button and review the comparison between the two files. So we're able to see that some strings has been added and some of the strings has been appended. So if we were to scroll all the way to the bottom of the file, we're able to see that some uh, Windows Windows path was picked up of the run DLL32, and also the file description of Windows Credential Manager was picked up. So they also picked up the original file name, which was Credentials.dll, which is one of the file names this malware goes by. So to going back to Process Explorer, we also are able to take a look at any mutexes created by the malware. In this case, some mutex may include the session 1 base name objects, will staging 02, and dbwin mutex. So if we were to copy this mutex names, we would search it up in the strings that was in the memory as well as the image of the malware. So if these names are actually found within the memory file or the image files, it means that this mutex belongs to the malware. So we can actually see that neither of the mutex can be found. So this could mean that the mutex that is created was not by could have possibly not been by the malware, but the other DLLs that are running within the system. So moving on to process monitor. So we first create a filter. So using the filter, we are going to filter by the process ID, and the process ID of the run DLL32 is 1776. So after that, we will add the filter and we'll filter the process monitor by the process ID of 1776, which is run DLL32.exe. So after we have filtered it by the run DLL32.exe, we will actually scroll down to look for the malware.dll file. So once you actually see the malware.dll file, we are able to see that some creation of file mapping, some registry operations are actually taking place. So this could mean that the malware may be trying to modify some things within the registry and is also creating files and file mappings. So another thing that is interesting done by the malware will be to query basic information. So we are able to see that they are attempting to query some basic information as well as querying of some security files. So this could mean that the malware.dll is attempting to query for some information for them to actually capture and using the POP3 protocol that we found from the network operation. So, this may be the information being sent over by the malware. So after we have analyzed the processes created, so we'll be looking at the registry operations next. So to analyze the registry operations done by the malware, the red shot tool is used. So the red shot tool is configured to actually scan the directory of the entire C drive to ensure that any files that is any files that is created or any registry operations done by the malware is captured, after which the first shot is taken. So this first shot will capture the state of all the processes and any running processes and the information will be used to compare with the second registry shot, and the differences will be outputted. So the first shot is usually captured before the malware is executed, and the second is around a minute or two after the malware has executed. So after the first shot has been taken, the information about the device will be outputted and the malware is executed. So after this malware has been executed, we'll wait around 1 to 2 minutes before we capture the second shot. So once about 1 to 2 minutes has gone over, we'll take our second shot. So once the second registry shot has been taken, again the output values are shown. And after which we press the compare and output. So this will output all the information of the changes that was found to be have been made by the entire system and output it into a text document. So once the output is done, we can actually analyze the malware. So over here we see that there is some keys that has been added and deleted, and within the values modified, there is some audio journal render software. So this could possibly be something that the malware may be trying to disguise as also. So and if we were to scroll further down, we are able to we are able to see that there is some text which seems to be encrypted. So if we were to copy this out and we were to type it in, so looking at this, it looks like a rotation cipher. So we can actually see that rot 13, it will give us a UEME CTL session. So we can also scroll down further and we'll see more like pzq.rkr. So if we were to copy this and we were to input this, is the command prompt, and so and another drive which seems a little suspicious. So it's actually the red shot tool. So other than that, it seems that not many other registry operations or any file operations were being conducted. So that is all for the basic dynamic analysis.